Okay, now in this section we'll continue with the standard ACL where we have left in the previous session. Like we have seen some of the basic command line. If you just get back to the router 2 command line, I wrote an access list. We are writing these rules in a file, and then 15 is the number where I'm going to say this is my standard ACL, deny, and then IP address 1.1, and if I use question mark, it is asking me the wildcard bits. Now wildcard bits is something we need to define, but before we define the wildcard bits, we need to understand what is exactly wildcard bits or wildcard mask. Now wildcard mask is something used to match the portions, and it's going to tell how many portions to match or how many portions to check, where one is a must match or must check, and whereas one represents ignore. Sorry, 0 means must match, and whereas 1 is ignore here. So in the normal formula which we use for calculation of the global wildcard mask is from all 255s, that is my global subnet mask, we need to subtract the subnet mask. So let's take an example. I'm going to use 192.168.1 network. So I want to deny the complete network, 192.168.1 network, or I want to match the complete network, I can say. Okay, now permit or deny, that is secondary thing. And then I need to write the wildcard mask. So I'm going to assume the default subnet mask of this network is 255, 255, 2550. And if I subtract from the global subnet mask, subtract my subnet mask, I'm going to get a wildcard mask of 0.00255. So I'm going to write 0.0.0.255. Now what exactly it is going to do? It's going to tell how many portions of the bits you want to match. Now if I say deny, okay, anyway, deny or permit, it's secondary thing. It's going to say that match all the networks whichever starts with 192.168.1. So which means wherever there is 0, you must match. It should be exactly same. So if a packet is coming to the router with a source address of 192.168.10.1, so it says it's going to match the first portion. Yes, it is same. Second portion, yes, it is same, and it's going to match the third portion also. Now the third portion is not same. Here it is 1, here it is 10, so it's not matching. Okay, so that's what exactly wildcard mask will say. And wherever there is 255, nothing but wherever there is binary ones, if I write them in binaries, ignore. Ignore means it can be anything. So match all the addresses whichever starts with 192.168.1. That is what it is going to tell. So match all the addresses whichever starts with 192.168.1, and this portion can be anything. It can be any from 0 to 255, whatever it is, it doesn't matter. So it's going to deny. If I say deny, if I say permit, it will permit. It's going to match all the addresses whichever starts with 192.168.1. X means it can be anything. So let's take an example. If I write the same example 192.168.1.0, and the wildcard mask this time I'm going to write 0.0.255.255. This time it is going to match all the addresses whichever starts with 192.168. Now which means it's going to deny or permit, whatever we say, all the addresses 192.168, and the third portion can be anything, fourth portion can be anything because of 255s, and it's going to match all the addresses whichever starts with 192.168. Now similar way, if I take an example of the same thing 192.168.1 network, and where I want to match, I'm going to write the wildcard mask of 0.255, 255, 255, something like this. Now the meaning of this is it's going to match all the addresses whichever starts with 192, which means it's going to match all the addresses whichever starts with 192, and the remaining 3 portions can be anything in between 0 to 255. So the wildcard mask here is going to tell how many portions to match. So whenever we are writing, whenever you're writing the subnet mask, we generally write the subnet mask where the subnet mask tells wherever there is 1, that is network, wherever there is 0, that is host. And when you are matching the networks, we generally want to match only the network portions. So in case of wildcard mask, 0 is matching and whereas host portions we don't want to match, because host portions can be anything we want to ignore. So we are going to say don't, it can be anything, ignore, but match only the network portions. Okay, so it's very easy. It's going to tell what portion of the bits to check or not to check. 0 means must be same, 1 means ignore, it can be anything. Now it's very simple. If you're using default subnet mask, just reverse 0 to 255, reverse and reverse it, but don't go with the reverse kind of things. Probably if you're preparing for certification exams or some scenario based questions, you may not be using the default subnet mask. So if you're using something like this, like /28 240 /28, in that case we need to subtract from all 255s, so you get the wildcard mask here. So it's going to match only the network portion bits, in simple we can say. Okay, so just remember the formula. Minimum you have to remember the formula and how to calculate. Now the final thing, whenever you are writing or defining any network, we need to write inverse mask. Now inverse mask is nothing but these formulas we need to use for the calculation. Whenever you want to write in the ACL, you want to match any networks. But what if I want to deny a specific host? So I want to deny 192.168.1.1, where I want to deny a single host. Can I write a wildcard mask of 0.0.0.255? If I do that, what happens? It's going to deny all the addresses whichever starts with 192.168.1, and the fourth portion can be anything, which means it is going to deny 1.1, 1.2, 1.3, 1.4, 1.5, all the addresses till 255. Now this is going to deny the complete network, but not the single host, which means this is something wrong in my scenario. So to deny a single host, we need to write something like this. We need to write the wildcard mask of 192.168.1.1, and the wildcard mask will be all zeros. So all zeros means exactly matches all the 4 portions. It has to be 192.168.1. If it is 1, then only deny or permit whatever you say, or else. So whenever writing a single host, the wildcard mask should be all zeros, something like this. Now either we can write like this, or there is one more way to write. We can write host space IP address. So I'll just come back in the command line. So either we can write 192.168.1.1 with a zeros wildcard mask, or we can write something like this. Okay, so we are done with our wildcard mask. Now let us get back to our example here, because we have stopped in between on the router 2. We stopped here, wildcard mask. Now what's the wildcard mask I have to write here? 0000, because I'm not defining a complete network, I'm just defining one single host, and for the wildcard mask should be all zeros. A similar way, what is the second rule? Second rule is also access list number 15. So I should not change the number. So if I change the number, it's going to make it as different ACL. So it is something like matching all the networks, and I'm going to match all with the ACL 15. It can be any number, but if you change it to 16, it becomes different ACLs. So use the same number, access list 15 deny. Now one method, either I can write 192.168.1.2 with all zeros, that is one method, or I can just write as host space IP address without wildcard mask. So both are correct, but you should know both the options. That's the reason I have given both options here, but both are correct. And again, writing the next tool, access list deny. I want to deny 192.168.3. network. So this is my complete network. So write the destination source address and then the wildcard mask 000.255, and then after that I need to say permit any. Now permit any is mandatory, because if you are saying deny and you are not saying whom to permit, so in that case what happens is by default it will stop everyone. So we need to say deny all these users and permit all the remaining. And permit is something, we have many permit statements, so saying each and every permit is not an easy job. So that's the reason I'm saying deny this, and permit all the remaining in the last. Done. So now to verify this access list, we can use a command called show access list. I can see what are the rules I have written. These are the rules. And if you want to see the exact command line configurations, we can use show running config. If I give show running config, I can see the exact command lines what I have created. Now we are done with our second step, where we have created an access list based on the syntax exactly the same. Now the last part is implementation. Now implementation is one of the important thing here, and we need to implement. Right now we are implementing on the router 2, that is where we have created an ACL. Now implementation is done on the interface. So which means now in this scenario, either I can implement on this interface, which is my S0x0 interface, or I can implement on S0x1 interface, or I can implement on F0x0 interface. Now deciding the right interface is the first important thing. Now which interface? That's the first question you have to ask yourself, on which interface should I implement. So what if I go with this interface? Let's try on this interface, ACL. So if I implement on this particular interface, what happens is, now let's say 1.1 user is trying to communicate with 2.1. The packet come from here, it will go on this interface, and this ACL says stop, I have some rules to check. It's going to check the source address, and it says 1.1 is in the deny list. It's going to simply drop the packet. But the problem here is, if 1.1 is user also trying to communicate with 3. network, the same thing happens, it will drop the traffic. The packet goes from router 1, goes to router 2. Router 2 says on this interface, ACL says what is the source address, 1.1. 1.1 is denied. Because the standard ACL, it will not check the destination. It's not checking whether it is going to 2. or 3. So which means implementing on this WAN interfaces, it's going to impact the communication between 1 and 3 also, and that is something I don't want. So which means these two interfaces are not the appropriate interface in this scenario. Again, in this scenario, it may vary based on your scenarios if you're using different kinds of rules. But in this kind of scenarios, if I implement on this interface, it will also stop the communication between 1 and 3, which is something I don't want. So the most common implementation is done nearest to the destination. Nearest to the destination, mostly on the LAN interfaces, because this is my destination and the nearest interface to the destination. That's something recommended when you are implementing a standard ACLs. So now deciding the right interface is important. So to implement, I need to go to my interface. What's my interface? I need to go to interface. It's an interface F0x0 on the router 2 again. So the command starts with IP access group, and then the ACL number we need to tell. I'm using ACL number of 15, and then there are two options you'll find here, in or out. Now this is very important thing, deciding the right direction. Now here, this is my F0x0 interface. If I just get back to my slide here, now deciding the right direction is more important. But before you decide the right direction, first you should have a clear idea on what is the right direction. Now if you just ask yourself, this is my interface F0x0 where I'm implementing the ACLs. Now I have question like, this is my direction and this is my direction. I got two directions here. Now if I ask you, this direction is whether it is in or out, normally what you will think? So now in this, it will be, normally we think this is in, this is out. That's what generally we think in general, but it is opposite. Now this is not in, this is out actually, this is in. Now when you are deciding, you should not check based on the destination. So normally what we'll think is, normally where I used to think initially the same way, like when I was reading ACLs initially. So when a packet is coming from here, we think this is the source and it is going from here. Now this is the destination here, and we think this is in, and that's something wrong, because the problem here is the ACL is not on the LAN, it is on the interface. Now I'm implementing on this interface. Now anything coming towards the interface is in, towards the interface where you implement ACLs, and anything going far from the interface is out. Now in my scenario, if I take this as my interface, this is my in, this is out. Always remember, into the router interface, if you are implementing on this interface, this is in, this is out, because it is far from the router. And similarly, if I am implementing on this interface, this is in, this is out. So this is very important point we need to keep in mind, because when we implement ACLs, we should have a proper understanding of which is in, which is out. Suppose if I am implementing on S0x0 interface, this is in, this is out. Suppose if I am implementing on this interface, this is in, this is out. But anyway, we are not implementing on the interface S0x0, we are implementing on F0x0. Right now this is my in direction, this is my out direction. Into the LAN, into the interface, out of the interface, or into the router, out of the router. Now we need to decide. So the first step is we need to know the exact in and out, which is correct. And the next thing, we need to decide whether we need to implement the ACL whether inbound or outbound. So that can be decided by assuming some packets. Let's say I'm sending some packets from 192.168.1.1 and I'm trying to send to the destination address of 192.168.2.1. According to my ACL, this packet should get dropped. Now we need to see if a packet is coming from 1.1, it goes to router 1. Router 1 checks the routing table and forward it back to router 2, and the router 2 is going to check the routing table again. It forward backs on F0x0 interface and it goes here. Now if you see the direction, of when it comes on this interface, whether it is going far from the router or coming towards the router. Now if it is far from this interface, then we call it as out. If it is coming towards, we call it as in. Right now, which side it is going? It's far from the router, which means I want my router 2 to drop the traffic when it is before it goes out of this interface, which means out direction. I'm saying router 2, if any packet is going out of F0x0, before you send out, check with some ACL rules. And if it is matches the specific source address, and if it is in the deny list, deny them. If it is in the permit list, permit them. That's something how it's going to work. So deciding the right direction is very important, and normally it's very simple. Generally we think that it's very simple, just try with in, or if it doesn't work, try with out, but that's something not correct. You need to have a clear understanding on how it's going to forward, or how we are going to select the right direction. So implementation part, let's go to router 1 and then configure that, on the router 2, I just need to go to interface F0x0. I just need to say IP access group. That's how we implement. ACL number is 15. That's what I have created. Now there are only two options, in or out. If you try in, it is not going to work. I'm saying that any traffic going out of this interface, before it goes outside, it has to be checked with the ACL rules 15. Now let's get back to our diagram. On the router 1, or the router 2 I can say, according to my deny rules, 1.1 to 2. Communication is stopped, right? So let me just go back to router PC1. This is my 192.168.1.1, and I should not be able to communicate with 2.1. Now you can see the reply is not coming. I can see when I'm sitting on 1.1 and I'm trying to communicate with 2.1 according to our rules. Now your packet is traveling to router 1 and router 2, but the router 2 is not sending back because of the source address is in the deny list. So the reply is coming from here. It says that I'm not able to send because there is something denying over there. Now whenever you see this kind of message, now there are two possible cases. Either this interface is down, the LAN interface, or there must be something dropping on that interface. Now in my scenario, there is an ACL which is dropping on that interface. Similar way, if I try from 3.1, also Like in the previous case, I was able to get reply. So I'll try to ping from 3.1. This is my 3.1 PC. If you want, I can check. And I'm trying to ping to 192.168.2.1, and you can see the same thing, same result almost. You can see the packet is coming from 3.1, goes to router 2, and the router 2 says, before I send, I'm going to check the ACL, and in that ACL 3.1 or 3. Network is denied. Even if you try from 3.2, 3.3, 3.4, any computer from here, it's going to have the same result, because the complete 3. Network is in the denial list, and we are getting a reply from 11.001. But if I try to ping to 192.168.1.1, you can see it is not impacting the communication between them, because 3.1, the packet goes to router 3, router 3 forwards to router 2, and the router 2 forwards to router 1, and it's not going on this interface. Now it's not all going on this interface. If it goes on this interface, then it will drop, but it's going from here, so it will communicate without any problems. So that's how the standard ACLs are going to work. And the major important thing we need to decide is the direction. That's something a little bit more complicated, or the actual understanding. We need to have an actual understanding on the right direction, and anything coming towards the router interface is in, anything going far from the interface is out. And based on that, you have to decide the flow of the traffic. If it is going far from the interface, you have to select out. If it is coming towards the interface, you have to select in direction.